Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start part 2 of 12th. Last class I have finished 11th part of this 12th part 1 I have finished completely. Now part 2 I am going to start. Last class I have finished coordination compounds. Now I am going to start part 2 of 12th. Haloalkanes and haloarenes. Halogenated compounds persist in the environment due to their resistance to breakdown by soil bacteria. This is the brief of haloalkanes and haloarenes. Halogenated compounds persist in the environment due to their resistance to breakdown by soil bacteria. The replacement of hydrogen atom or atoms in a hydrocarbon, aliphatic or aromatic, by halogen atom or atoms result in the formation of alkyl halide, also called haloalkanes, and aryl halide, also called haloarene, respectively. Again, you listen carefully. The replacement of hydrogen atom or atoms in a hydrocarbon like aliphatic or aromatic. These are the examples of hydrocarbon, aliphatic or aromatic, by halogen atoms. Replacement by halogen atom or atoms results in the formation of alkyl halide and aryl halide. Alkyl halide is called haloalkanes, and aryl halide is called haloarenes. Haloalkanes contain hydrogen atoms attached to the sp3 hybridized carbon atom of an alkyl group. sp3 hybridized carbon atom, sp3. And this in haloarenes contains halogen atoms attached to sp2 hybridized carbon atom or atoms. They are the difference. Haloalkanes contain halogen atom or atoms attached to the sp3 hybridized carbon atom of an alkyl group, whereas haloarenes means benzene group I am talking on, in benzene chloride में attached. That is the haloarene. Arene means here benzene ring, you can consider. In benzene ring, halogen में attached, not में will be attached. Haloarenes contain halogen atom or atoms attached to sp2 hybridized carbon. sp2 hybridized carbon atom or atoms. These are the difference. In haloalkanes, halogens will be attached with sp3 hybridized carbon, whereas in haloarene, halogen will be attached to sp2 hybridized carbon atom or atoms. Question is asked. Now I have discussed. Many halogen containing organic compounds occur in nature, and some of these are clinically useful. These classes of compounds find wide applications in industry as well as in day-to-day life. They are used as solvents for relatively non-polar compounds and as a starting material for the synthetic of wide range of organic compounds. Chlorine containing antibiotic, as for example, chloramphenicol, chloramphenicol, CHLOR, chloramphenicol, AMPHENICOL, chloramphenicol. This is antibiotic. Chlorine containing antibiotic chloramphenicol produced by soil microorganism by very effective. These are produced by soil microorganism and this is very effective. It is very effective for the treatment of typhoid fever. In typhoid fever, this chloramphenicol is very effective. Our body produces iodine. Our body produces iodine containing hormone. Thyroxine, its name is thyroxine. Our body produces iodine containing hormone called thyroxine, the deficiency of which causes a disease called goiter. Synthetic halogen compounds, as for example, chloroquine, okay, chloroquine, CHLORO, chloroquine, QUINE, quine, chloroquine is used for treatment of malaria. Okay, chloroquine, QUINE, chloroquine is used for the treatment of malaria. Halothane is used as an anti. Halothane, THANE, halothane is used as an anesthetic during surgery. Correct? Halothane, THANE. Halothane is used as an anesthetic during surgery. Certain fully fluorinated compounds are being considered as potential blood substituted in surgery. Again, it is very important. Certain fully fluorinated compounds are being considered as potential blood substitutes of surgery. Okay. In this chapter, we will study the important methods of preparation of physical and chemical properties and usage of organohalogen compounds. Okay. Now I am going to discuss haloalkanes and haloarenes. Okay. This classification, I am telling classification on the basis of number of halogen atoms. Classification on the basis of number of halogen atoms. Then here first I am telling you classification. Haloalkanes and haloarenes may be classified as follows. These may be classified as mono, di or polyhalogen. Polyhalogen means tri, tetra, etc. Okay. These compounds may be classified as mono, di or polyhedron compounds depending on whether they contain one, two or more halogens, more halogen atoms in their structure. For example, that C2H5X, C2H5X, only one X is there. Then it is called mono haloalkanes, because C2H5 came from the alkane. One hydrogen gone out, and in its place one X came. Means one hydrogen substituted with one X. X means halogen. That's why it is called monohaloalkane. X may be chloride, bromide, fluoride, chloride, bromide, iodide. Okay, this is called monohaloalkane if only one X is there. Now dihaloalkane. Now two X is attached with ethane. In ethane, two carbon is there. Each carbon has 3 hydrogen. Then from each carbon, one hydrogen just substituted by one X. Then now 2X came in the place of 2 hydrogen. On each carbon, one hydrogen substituted. Means one H gone, one X came. Other carbon also, one hydrogen gone and one hydrogen came in its place. That's why it is called dihaloalkane. Like that way, trihaloalkane. If in propane, on each carbon, from each carbon, one hydrogen will go, and its place one X will come on each carbon. Then now CH2X, CHX, CH2X. This is called trihaloalkane. Trihaloalkane, because 3 X are attached. 3 X are attached with alkane. Alkane is here propane. And dihaloalkane, in that it was ethane. Here alkane means ethane. And in monohaloalkane, it was, again you can say ethane. Alkane means here ethane, C2H5X. That is the monohaloalkanes. CH2X, CH2X. That is the dihaloalkane. And 3X is attached with propane. Each hydrogen, each carbon has replaced by one X. That's why name has been given trihaloalkane. Now come to the arene. Arene also same way. Means from benzene, you know that 6 carbons are there in benzene, and on each carbon one hydrogen is there on each carbon. Then here also hydrogen may be replaced with X. X means halogen. Then here same way, one hydrogen may be replaced. Sometimes 2 hydrogen may be replaced by 2 carbon. Sometimes 3 hydrogen may be replaced by 3 carbon of benzene. Then when 1 hydrogen is replaced by 1 X on benzene, then it will be called monohaloarene. Mono means 1, halo means halogen. Halogen means maybe X may be fluoride, chloride, bromide, iodide. That's why name has given monohaloarene. Arene is for benzene. Okay, benzene. That's why haloarene, A-R-E-N-E. Monohaloarene. Same way, if 2 hydrogen is substituted with 2X, then it will called di. Di means 2, halo means halogen, maybe fluoride, chloride, bromide, iodide. Then dihaloarene. Like that way, if 3 hydrogen is replaced with 3X, then it will be called trihaloarene. Monohalo compounds may further be classified. Monohalo compounds may further be classified according to the hybridization of the carbon atom to which the halogen is bonded. Okay, then I am telling you that because sometimes carbon may be sp3 hybridized, Sometimes carbon may be sp2 hybridized. Sometimes carbon may be, you can say, sp also, sp3, sp2, sp. Okay. Then where carbon is attached, then this mono halo compounds may be further classified according to the hybridization of carbon atoms to which the halogen is bonded. Okay. Now first I am telling compounds containing sp3. Compounds containing sp3 carbon X. X may be fluoride, chloride, bromide, iodide. CX bond will be there. CX bond. Then X is halogen. Then this C is sp3 hybridized. sp3 means carbon, carbon have 4 valency. Correct? You know all the thing. Carbon atomic number is 6. Then its electronic configuration is what? 1s square, and 2 electron is in S, and rest 4 are in p orbitals. Then 1s square, p4, 1s square, p4. Okay. Then this I told you this total 6 electronic configuration. If you write, then 1s square 2, 2s square 2p2. Total in the last orbit 4 electrons are there. 4 are there. In first 1s square means 2 electron is over. Now in second orbit s or p are there. Then 2 electron will go to 2s and rest 2 electron will go to 2p. Okay. Then here in general you can write electronic configuration like in first orbit 2, in second orbit 4. Then 4 will be arranged like 2s square 2p2. Then here you should understand that total 4 electrons are there in orbit number 2. Then what will happen, that this is in a normal condition. This is in a normal condition 2s square 2p2. You know that excitation takes place in a last orbit. Generally excitation will take place in a last orbit. Then here on excitation 1s square electron, 1 electron from the 2s square, 1 electron from the 2s square will go to the p orbital. Then now in p orbital 3 electrons are there. Each p will have 1 electron. px, py, pz. Its total capacity is 6. You know, p has 6 capacities. It can accommodate 6 electrons. px, py, pz. Then now 1 electron from the 2s, it went to the 2p. Then px, py, pz have 1 electron each, and 1 electron is remaining in 2s. Then total 4 orbitals are there. First orbital is 2s, and after that 3p. Then after excitation, now this 3p and 1s will hybridize. It will take part in hybridization, and it will form sp3. It will go for sp3 hybridization, 2s and 2p, and 4 orbitals after hybridization. All 4 orbitals will have almost same energy, equivalent energy, all 4, and after hybridization it will form 4 orbitals, and its name will be sp3, 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 sp3. Why? Because all have almost same energy, same equivalent energy, you can tell, not 100% same. Then this is actually sp3 hybridization. Correct? Here only I want to tell you Actually, there is a rearrangement of orbitals from S and P. What is its purpose? Now S has different energy. Before hybridization, S has different energy and P orbitals has different energy. But after hybridization, all orbitals will mix. All 4 orbitals will mix. They will share energy and they will form 4 orbitals only, but of equivalent energy. Not 100% equal, equivalent energy. 4 orbitals they will make, and its name will be sp3, sp3, sp3. Then total 4 s, 1 s and 3 p, 4. Okay. Then 4 orbitals it will make, sp3, 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 sp3. This is called sp3 hybridization. Same way, here again one example I will tell you for better understanding. Suppose you are playing on the sand and you have made 4 sphere of sand. 4 sphere of sand. And also you consider that all 4 are of a different color. Different color. Maybe one may be yellow, other may be red, blue, green. Correct? But now, if you will mix all 4 completely, again you will make 4. Then now, all color will be distributed. In all 4 spheres, you will find all 4 colors. Correct? Then, same thing is there. After mixing the hybridization, you will get same number of orbitals having equivalent energy. Means equivalent color in a sphere, sand sphere, you will get every type, in all 4 you will get every type of color. Same way, sometimes maybe in a sphere little minor change will be there in color, but almost same color you will get in all 4 after mixing and making new sphere. Then here same thing happens in hybridization. Then this is the sp3 hybridization I told you. Same way, if 1 s and 2 p orbital will mix and it will form sp2 hybridization. After mixing, it will form 3 orbitals, 1 s and 2 p. Then it will call sp2 hybridization. And 1 electron will be left out. It has not taken part in hybridization. Okay, like that way, when 1 s and 1 p orbital will take part in hybridization, then it will form sp hybridization. Sp hybrid orbital, it will, after the becoming this hybridization, hybrid form is called, orbitals form is called hybrid orbital. After hybridization, what you will get orbital, that is called hybrid orbital. Then now in sp, 1s and 1p mixed, then it will form 2 orbitals, sp, 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 2 orbital, and this is called sp hybrid orbitals. Process is sp hybridization. Then now 2 electron has not taken part, means 2 orbital has not taken part in hybridization. Then what is the role of this? These you can say orbitals which has not taken part in hybridization. What will they do? In sp2, one orbit has not taken part, unhybridized, and in sp 2 orbitals are unhybridized, not taken part in hybridization. Then what will be its role? Then its role will be in the formation of a pi bond. Correct? That sp2 in sp2, after the formation of sp2, 1 was left. Then that will take part in formation of, you can say, side-wise overlapping, it will form 1 pi bond. And in sp, 2 have not taken part, then these 2 will take part in overlapping with other carbon. Let's suppose 2 carbons are there. Now I talk with one carbon. 2 carbon is there. Then there also same situation will be there. Then sp2, 2 carbons are there in each one. One is remaining, has not taken part. Then both will overlap, side-wise overlapping. Then pi bond will be formed between carbon-carbon. Same way that if 2 carbons are there, each will have 2 unhybridized. And they will again overlap. And this time they will form 2 pi bond. 2 pi bond. Side-wise overlapping. Okay, it is called side-wise overlapping or lateral overlapping. Then now I have told about the hybridization. Previous class also I have discussed. Now here I told you that halogen can attach to the carbon which has sp3 hybridization. One case is this. Then example of this is a primary. Okay. This alkyl halides, in alkyl halides, the halogen atom is bonded to an alkyl group, alkyl R group, capital R, alkyl group. They form a homologous series represented by CnH2n plus 1x. This is called homologous series. Only one X is there. Only one X. CnH2n plus 1. Remember, this is very, very important formula of alkane. Important formula of alkane. You can make homologous series. Homologous series. CnH2n plus 1 X. Then now, if suppose n is equal to 1, then what it will form? Cn means CH2n means 2 plus 1, CH3, CH3X. This is called alkyl halide, methyl halide. It only because only one carbon is there. One carbon, CH3 now, X. Fourth carbon gone, X carbon came, X halogen came. Okay, then now it will form CH3X, first member of the homologous series. Like that way, that is actually alkyl series. This is called alkyl group, alkyl series, alkane series you can tell. And R is called CH3, like that it is called alkyl. X you don't count, then what is remaining? That is called alkyl. Then CH3. Now if 2 is there, in this formula I put the value 2. Then you will get C2H5X. Then C2H5 is again second member of alkyl, ethyl. Methyl, ethyl. Like that way you will put 3. Then you will get C3H7X. C3H7X means propyl. And then methyl, alkyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, all are called alkyl group. And it all came from the alkane. That's why it is called alkyl. And X is attached here. That's why it is called alkyl halide. And this chlorine atom or chloride is attached with sp3 carbon. sp3 carbon. Okay. Then here, now we can understand different halide, where it is attached according to that. Then they are these homologous series. This homologous series, I told you it is represented by CnH2n plus 1 X. They are these series are further classified as primary, secondary or tertiary according to the nature of carbon to which halogen is attached. Then primary is attached with the carbon, and that carbon, that actually X is directly attached to the one carbon only, and other their carbon are where it attached. In that carbon, two hydrogen is there. Two hydrogen is there, and with that carbon, alkyl group is attached. R or R dash, whatever you want, you can tell. Then now that R, C, and with this is 2H is there, CH2, R, CH2. Okay, two hydrogen is attached. Actually, third carbon is replaced by alkyl group, R dash, you can tell, R dash. Alkyl group, one hydrogen out of four hydrogen, one is substituted with X, and one hydrogen, other hydrogen is substituted with R dash, you can tell. Then now only two hydrogen is remaining. Then this is called primary halogen, because that X where it is attached with that X, only one carbon is, means alkyl group is there. Okay, that from that carbon one alkyl group is attached. Then alkyl group may be methyl, maybe ethyl, maybe propyl, but whatever be, that with the first carbon, second carbon is attached. Even ethyl is there. Then this carbon is attached with other carbon. Okay. Then total carbon has 4 valency due to 4 orbitals. Then now one orbital is attached with X, other orbital is attached with, other two are attached with HH, and fourth one is attached with other carbon of alkyl, like R dash. Then this is called primary. Now if suppose this carbon, the carbon to which X is attached, if that carbon is attached with two carbon, correct? Maybe now other alkyl group is attached, maybe methyl group. Suppose in the beginning ethyl was attached, one hydrogen was replaced with one alkyl group like ethyl. Now other hydrogen also is replaced with other alkyl group like methyl. Then now this carbon is attached with two carbon. One is from ethyl, other is from the methyl. Now only one hydrogen is remaining. Three hydrogen is replaced, fourth one is replaced. Three hydrogen replaced, two with alkyl, one with halogen, and one hydrogen is remaining. Then now you can write R dash. They have made bond with carbon. Third is hydrogen. Original is hydrogen, and fourth one is with X. Then now because this carbon is attached with two alkyl group means two carbon atoms, total 3, including this carbon 3. In the first case, in primary 2, it was attached with extra 1, okay, total 2. Now it is attached with two carbon with two alkyl group, total 3. Then because it is attached with two alkyl group, then it is called secondary halogen. Like that way, if it is attached with 3 alkyl group, R1, R2, R3, then now no H is remaining. All 3 H is replaced with different alkyl group. Maybe one was ethane, other was methane, third one was, suppose, propyl group. Then methyl, ethyl, propyl. 3 hydrogen replaced, 3 group came. Methyl, 3 alkyl group. Methyl, ethyl, propyl, and fourth one is replaced with halogen. Then because this time this carbon, halogen attached to the carbon, that carbon is now attached with 3 alkyl groups, and each alkyl group means where it will attach, then it will attach with the carbon of that alkyl group. Hence, when carbon to which halogen is attached, if that carbon is attached with three other carbon of three alkyl group, then it is called tertiary. Tertiary. I think now you have understood, and you have understood the meaning of primary, secondary, and tertiary halide. Okay, primary means that carbon has attached with other carbon of alkyl group, and in secondary it is attached with two carbons of other alkyl groups, and in tertiary it is attached with three carbons of three other alkyl groups. Then now I discussed about these things, classification, and means compounds containing sp3 carbon, and that sp3 carbon X is attached. Then this is the classification, one classification. Now alkyl halide or haloalkanes. Haloalkanes, Rx. In general way we are telling Rx. R means alkyl, X means halogen. Now I can say this is the sp3. In all you can say this carbon are sp3 hybridized in all three, primary, secondary, tertiary. Okay, 4 bond means carbon has 4 bond, single, 4 bond, single. Then each bond is telling about each orbital, 4 orbitals, and 4 orbitals means what? sp3, total 4. One is 3p, sp3, 4. By seeing the bond you can understand number of single bond. Now you can see allylic halide, allylic. Now here what you will get? You will get this thing, double bond, carbon, at least one double bond will be there, double bond. That is called allylic. On this double bond, this carbon double bond, in that X may be attached. X may be attached by replacing one hydrogen. What is the allylic halide? Allylic halide, second type of halide I am talking about. Then these are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom next to carbon double bond. As for example, an allylic carbon means here suppose 3 carbons are there, then C and C, double bond is there, correct? And after that next C is single bond. Total 3 carbons are there. Then first carbon and second carbon single bond, and second and third suppose it is double bond. Then now carbon has 4 valence, you know, then rest will be the hydrogen. Means first carbon single bond. It means first carbon will have 3 hydrogen. Second carbon, 2 bond is there between C and C. Then only 2 and 2 double this 2 bond, and with this side right side 1 bond. Then total 3 orbitals are used up for the second carbon second and third carbon double bond. Then 2 orbital is used up and 1 orbital used up with first carbon. 3 orbitals are used. Only 1 is remaining. Then with second carbon 1 H will be there, and with first carbon 3 hydrogen will be there, because only one orbital is used up, 3 are remaining. Then just you can consider it is H only, means first carbon is CH3, second carbon is CH, and now suppose third carbon is now, because in the middle 2 are there, then two hydrogen will be there with third. Now CH2 means 2 orbitals and 2 orbitals in bond formation. Double bond formation. To make one bond, 2 orbitals are required. Correct? Each carbon will donate, each orbital will contribute one orbital. Then here double bond means each carbon has donated 2 orbitals. Then 2 hydrogen is there on the third carbon. Okay. Now in this situation, now you think, suppose three carbons are there. Then that the first carbon is suppose single bond and second, third double bond. Then now with first carbon 3 hydrogen is there. Now you consider 1 hydrogen is replaced by 1 halogen. Maybe CX, maybe chloride, bromide, iodide. Then now 2 hydrogen is remaining. Then now this carbon, first carbon is also sp3 hybridized, first carbon. But second and third carbon is sp2 hybridized. Correct? First carbon is sp3 hybridized, second and third sp2 hybridized. Then if halogen is attached, if halogen in this type of compound, allylic halides I am talking about, these are the compounds in which the halogen atom is bonded. Halogen atom is bonded to an sp3 hybridized carbon atom next to carbon-carbon double bond. Okay. Then this is the second type of allylic halide, allylic. Always understand that one double bond is there. One double bond is there, and after that one carbon is there. In that is sp3. In that carbon, halogen is attached, not on the second double bond, not on the carbon having double bond. You remember. Now same way benzylic halide, benzylic. Now in benzene, alternate double and single bonds are there. 3 double bonds, 3 single bonds. Then on each carbon, you can say that one hydrogen is there. In benzene, 6 carbons are there, ring. Correct? Then alternate double and single bond is there. Sometimes you can write one circle inside the ring because these double bonds are rotating, and all bonds is considered as a equivalent bonds. Okay, but now here you understand alternate double and single bond. Then here again same way in benzylic halides, these are the compounds in which the halogen atom is bonded to an sp3 hybridized carbon atom next to an aromatic ring. Correct? Means aromatic ring is there. 6 carbon ring is there. With that, suppose one more carbon is attached. By removing one hydrogen, one carbon is attached. Correct? Methyl group, suppose it is attached. CH3. Correct? Then this CH3 and fourth one orbital is used up in making bond with benzene. Benzene carbon is there. Then the carbon to which methyl group is attached, there also H has removed from that carbon benzene ring. Any carbon you can consider from that hydrogen is removed, and this methyl group is attached. Then both has contributed one orbital of the carbon of benzene. Carbon of benzene, one orbital, and one orbital from methyl. Then they have made single bond. Then now in methyl group 3 hydrogen is there. 3 hydrogen. Then now suppose, but this carbon CH3, it is CH3 and one bond, and total 4 is used up. This is also sp3 hybridized. This carbon is also sp3 hybridized. And now out of this hydrogen, suppose one has replaced by halogen. Then now only 2 hydrogen will remain. CH2, X it form. X is halogen, maybe fluoride, chloride, or bromide, iodide. Then this is actually called benzylic halide. Benzylic halide. Okay. Then now here again you can say, this cases, first cases primary you can tell if with this carbon 2 hydrogen is attached and 1 X is attached, then it is called primary. Now suppose 2 hydrogen is there. Now suppose one more hydrogen replaced with other alkyl group. Then now it will be called secondary. Okay. First was primary because benzene ring, one carbon from the benzene ring was attached with methyl. Correct? That's why it was a primary. Now CH2X primary. Now from that CH2 1H again just replaced with other, you can say, alkyl group R dash, as for example, and then 1H will remain. Then it will be called secondary. And now again third hydrogen is also replaced. Then what you will tell? Then you will tell tertiary. Then primary, secondary, tertiary is also possible here. Okay. Then if CH3 is there, if CH3 in the beginning, then it is a primary. And if R dash and R dash, okay, both are replaced. Second H is replaced with other alkyl group. Then it is called, now carbon is attached with that main carbon, first carbon is attached with the other two. Other alkyl group also attached. Then this is the secondary, one H is there. Now that H is also attached to the third alkyl group. Then in that situation it will be called tertiary. Okay. Then sometimes R and R dash, what we are telling, may be same. Not necessary that it will be different. May be same also. R dash, R double dash, R double dash, R double dash, or R dash, R double dash, R3 dash, anything you can write. All may be same also. All may be different also. Then this I have told about the this different type of halide. This is called benzylic halide because benzene is attached. Okay. On benzene, methyl group is attached, and from methyl group that hydrogen is replaced by X. Then everywhere now we have seen that X is attached with sp3 carbon. Now you see where X is attached to sp2 carbon. There is also cases that X halogen may attach to sp2 carbon also. Then sp2 carbon means what? Double bond. Remember, if a halogen is attached to the carbon having double bond, that is called sp2. Similarly, if this halogen is attached with the triple carbon, then in that case it will be sp hybridization. 3 means triple bond, just like in acetylene. You have seen acetylene, ethine, ETHYNE, ethine. triple bond. Then triple bond, then that time only one H will be there. Then now suppose that H is replaced by one halogen. Then now in that case sp hybridization is there, only S and only P. sp hybridization is there. Then halogen may be attached with the sp2 also and sp also. Then now I am telling little details that compounds containing sp2 carbon and X bond. It can make a bond between sp2 carbon and X. X is halogen. Then here one example I am telling you, vinylic halide. Vinylic halide. Then example of vinylic halide means here two carbons are there. Between the carbon, two double bond is there. And from that carbon, that both carbons are now sp2. Then halogen can attach directly, it can attach to that carbon. Okay. In any carbon, halogen can attach. Okay. Then vinylic halide. What is the vinylic halide? Then these are the compounds in which the halogen atom is bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. Okay. Like that way, you can say this also you can understand in benzene. Not in benzene, cyclo compound you can consider. Cyclohexane as for example. Cyclohexene you can tell hexene. Cyclohexene means inside the ring only one double bond is there. That is necessary to be called hexene. Hex means 6 carbon, and in that carbon this is the ring structure. Cyclic, it is a cyclic. Okay, hexene, cyclohexene you can tell. Cyclohexene, because cyclo this only will tell hexene, then maybe normal long chain, maybe long chain. Okay, normal n, small n. But here cyclic form, cyclohexene you can tell. Hexane means all will have single bond. All carbon bond will be single. But if you are telling hexene, En, you are telling hexene, it means at least one double bond is there. Then cyclohexene in a cyclic form, one double bond is there, and in that X may attach. Okay, then these I told you example of vinylic halide. Okay, vinylic halide. Then vinylic halides are compounds in which the halogen atom is bonded to an sp2 hybridized carbon atom of a carbon-carbon double bond. Then in cyclic hexene also you have seen that double bond is there. Then near that carbon only, in that carbon only it will attach. Because double bond is there, then obviously that will be sp2. Now another I am telling you which this compounds containing sp2cx, that is the aryl halide. Aryl means related to benzene. Then what is the aryl halide? Now you can understand very easily, and you know that in benzene all carbon is sp2 hybridized. All carbon is sp2 hybridized. Okay. Each carbon is sp2 hybridized. Then in any carbon halogen can attached. Then aryl halides, these are the compounds in which the halogen atom is bonded to the sp2 hybridized carbon atom of an aromatic ring. Okay. In any carbon, benzene ring is there, X can attach to anywhere in any carbon, because all are you can say having alternate double and all carbon has alternate double and single bond. Then X can attach to any you can say carbon which has double bond. in benzene ring. Then that is called aryl halide. Other example, now suppose in that benzene ring one methyl is attached. One methyl is attached. Okay, then one methyl group is attached in benzene, then it is called toluene. It is called toluene. You remember, CH3 is benzene ring is there and one methyl group is attached. Then methyl benzene also you can tell, methyl benzene also known as toluene. And if NH2 group is attached, then what you will tell? If on benzene NH2 group is attached anywhere with any carbon, then what you will tell? It will be called aniline. Aniline. These are the, you can say, aromatic compound. Aromatic compound, common way. Then now suppose toluene is there, methyl benzene is there, and now X is attached anywhere. X is attached with rest of the carbon. 5 carbons are there. Now it can attach, suppose, any other carbon which has a double bond. Alternate single double bond is there, you know. Then now suppose X is attached with the any carbon which has a double bond. Then what you will tell of this compound? Then it will be chloromethyl benzene. Chloromethyl benzene. And this is also example of aryl halide. Okay. Then I told you that this compounds containing sp2CX bond. Correct? Vinylic halide I given example, double bond in a normal chain, or also in hexene, cyclohexene I given example. Aryl halide also I have discussed. Then today I am stopping only here, and next class I will start nomenclature of alkyl and aryl halide. Okay, a special nomenclature. Thank you.